Exercise 1A, question number 1. Determine whether each of the following is a prime or composite number. So we have to sort out either these numbers are prime or composite. So first of all, let's see what are prime numbers. A prime number is a whole number having only two factors, that is 1 and itself. So those whole numbers which have only two factors, which are 1 and the number itself, they are called prime numbers. We can see that 2 is a prime since 2 has only two factors, which are 1 and 2. Another example of prime is 3. 3 has a factor of 1 and 3 itself. And there are a lot of more examples of prime number. For example, we have got 5, 7, 11, 13. These are all prime numbers. So a composite number is a whole number that has more than two different factors. So those whole numbers which have more than two different factors are known as composite number. As we can see that 4 is a composite number because it has got three factors, which are 1, 2 and 4 itself. So it has got three different factors which is more than 2. So 4 is a composite number. Another example is 6. As 6 has got three factors as well, which is 1, 2, 3 and 6. So we can see that 6 has 4 different factors. So 6 is a composite number. Now we have to sort out either 81 is a prime number or a composite number. 87 can be divided on the table of 3. So we can say that 87 and 3 2s are 6. The remainder is 2 and the 7 will come down. So 3 9s are 27. So 87 has got another factor other than 1 and itself, which is 3. So 87 is not a prime number, which is a composite number. Because every value has two factors fixed, which is 1 and itself. 87 has got a factor of 1 and itself as well, but other than 1 and itself, it has got a factor of 3 and 29 as well. So it is a composite number. And about 67 cannot be divided with any table other than 1 and 67. So we can say that 67 is a prime number. Then we have got 73. 73 is also not divisible by any other factor other than 1 and 73. So 73 is also a prime number. And we have got 91 in D part. So 91 can be divided on the table of 7. So 7 1s are 7. The remainder is 2. 1 will come down. So 7 3s are 21. So we can see that 91 has got factors 1, 7, 13 and 91 itself. So we can say that 91 is not a prime, so it is a composite number. Question number 2. Find the prime factorization of each of the following numbers, leaving your answer in index notation. So we have to factorize these values and we have to write the answer in the index notation, which is in the form of power. So first we have to factorize 72. 72 is 2 is even, so we can divide this with the table of 2. So 2 3 times 6 and 7 minus 6 will be 1. 1 will be given to the 2, which will become 12. So 2 6 are 12 and 2 1s are 2. 3 minus 2 will be 1, so 16. 2 8s are 16. And then 2 9s are 18 and 3 3s are 9 and 3 1s are 3. So we can say that 72 can be written as 2 times 2 times 2 times 3 times 3. As we have got 2 times 2 times 2, we can write this 2 to the power 3 into 3 to the power 2, because we know that if a dot a, which has power of m, and then the other one has got a power of n, we can just simply add their power since their bases are same. So m plus n. This rule is applied here. So 72 can be written as 2 to the power 3 times 3 to the power 2, which is our index notation and which is our answer. Next we have to factorize 187. So 187 can be divided on the table of 11. So 11 ones the 11, then 18 minus 11 will be 7. 7 will be given to the 7, which will become 77. So 11 7s are 77, and we have got 17 ones are 17. So 187 can be written as 11 times 17, which is our index notation as itself. Then we have got to factorize the 336, which can be done with the table of 2. So 2 ones are 2, 1 will be given carry to the 3, so 2 6 are 12, and 1 will be given to the 6, so 2 8 is 16, and then 2 8 is 16, 2 4 is 8, then 2 4 is 8, and 2 2 is 4, and then 2 2 is 4, 2 1s are 2, and 3 7s are 21, and 7 1s are 7. So 336 can be written as 2 times 2 times 2 times 2 and times 3 times 7. So we have got 4 2's, which can be written as 2 to the power 4 times 3 times 7. So this is our index notation for 336. Next we have to factorize 630. So with the table of 2, 2 3s are 6, and 2 1s are 2, 3 minus 2 will be 1, so 10, 2 5s are 10. So 3 1s are 3, so we can't divide 3 with 1, so we just have to pair these two up, and we are just going to put a 0, then 3 5s are 15. And then again with the table of 3, 3 3s are 9, 1 will be given to the 5, so 3 5s are 15. And then with the table of 5, 5 7s are 35, and 7 1s are 7. So 630 can be written as 2 times 3 times 3 times 5 times 7. Then 2 times, we have got 2 times 3, so 3 to the power 2 times 5 times 7, which is our index notation, which end our answer.